Hello, my dear students. Welcome back to Learn Physics. In today's video, we are going to discuss about the chapter Atoms. The topics covered are alpha ray scattering experiment, impact parameter, Rutherford atom model. Actually, yesterday morning I that's uploaded this video, but due to some technical issues, sound was not clear. So I thought I'll do it again. So here we are starting with Thompson's model of atom. In that, see, in Thompson's model, J.J. Thomson considered it as a atom as a spherical cloud of positive charges. In that, electrons are embedded inside it. So, positive charge ions are there, positive charges there. Along with that, here and there, electrons also will be distributed. That is like seeds in watermelon. That was the concept which Thomson's gave. Okay, so what are the limitations of this model? He could not explain the spectral series properly. He could not explain large angle scattering of alpha particle. So large angles, what is meant by large angle scattering? That one we will learn in the next session. Okay, so here next we are going to study about Rutherford's alpha ray scattering experiment. In this is the experimental setup. From the source, this is the source of alpha particle. Here alpha particle is coming and falling on thin gold foil, and here a circular detector of zinc sulfide is kept. Alpha particle, we know it is helium, He24. We are considering it as positive particle. Alpha particles are charges positive. So this positive charge is falling on the gold foil. When it is falling on this gold foil, Rutherford and Yeager-Marsden, this is mainly known as Yeager-Marsden experiment, and they did along with Rutherford only. Okay, so during this experiment they understood that most of the alpha particles are coming to the other side without getting scattered, without much deviation. Most of the alpha particles are coming to the other side. Only very less a number is getting scattered, and more than 90-degree deviation is happening for very less number of particles. Okay, this was the observation which Rutherford got. And as per Rutherford, here what are the observations which made by Rutherford? The observations are most of the alpha particles pass straight through the gold foil, and the second one, about 0.14% of incident alpha particle scatter more than 1 degree. About 1 alpha particle in every 8,000 alpha particle deflects more than 90 degree. So this is what I told in with this previous slide. So alpha particles, most of them will be passing through the gold foil, but only a small percentage will be undergoing scattering about 1 degree, more than 1 degree scattering, and 1 in 8,000 only will be deflecting more than 90 degree. These were the observations which this Rutherford made. When he draw a graph relating the number of scattered particles deflected and the scattering angle, he found that we already understood from the previous experiment, for large angle scattering, number of particles getting scattered will be very less. So for small angles, number is very high. Here you can see here it is very high, and for 180 degree and all it is very less. Number of particles scattered is very less. So next we are going, the next one is impact parameter. What is meant by impact parameter? It is the perpendicular distance between the incident velocity vector of the alpha particle and center line of the nucleus. It is the perpendicular distance of initial velocity vector of alpha particle. This is the velocity. In this way only alpha particle is moving, right? So velocity vector will be in this direction. And the center line of the nucleus. So what is the perpendicular distance between these two? This is called as impact parameter. So next one, Rutherford's atom model. What are the points which Rutherford had given for his atom model? Every atom consists of a tiny central core called nucleus, in which entire positive charge and mass are concentrated. Second one, size of the nucleus is very small as compared to the size of the atom. Third one, atomic nucleus is surrounded by electrons. Fourth one, the electrons revolve around the nucleus in various circular orbits. This was Rutherford's atom model. Then next we are going to study about what are the limitations of Rutherford atom model. Rutherford said the electrons are revolving around the nucleus in circular orbits. But he told it will be losing its energy. While it is losing energy, what will happen? It will be spiraling inwards and finally fall into the nucleus. Thus, it is not able to explain the stability of atom. That is one of the limitations. The second point is, in Rutherford atom model says that it is a continuous spectrum. Why? Because it's continuously losing energy. It is continuously radiating energy. So it will be a continuous spectrum. But actually it is not a continuous spectrum. It is a line spectrum. So here you can see, in this, electrons will be losing its energy and it is spiraling inwards, eventually fall into the nucleus itself. So it is electron is not, for the atom it is not having any stability. So that one he couldn't explain properly. And the next thing is, in Rutherford atom model, he is since the energy, it is losing energy, it is considered as a continuous spectrum, but actually it is a line spectrum. These are the limitations of Rutherford atom model. Okay, clear children? So I hope it is useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.